Captain Kirk, we've got to have more time. The students, they're just now learning how to multiply, and they can't stop. They just keep multiplying 2 times 2 times 2 times 2. I don't know what to do. They're taking a lot of time to learn 2 times 2. Oh, exponents. Of course. Why didn't I think of that? I'll teach them exponents. Okay, let's consider multiplying. When we multiply 2 times itself 5 times, we could do it like this. 2 times 2 times 2 times 2 times 2 times 2. And we could go through all the steps of multiplying 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. And that's one way to do it. We mathematicians going very far back discovered that they needed a new way to symbolize multiplying something by itself many times. And so they came up with what we call exponents. And exponents can be used for so many things in math. They can be used in what's called scientific notation, and exponents. So exponents allow us to work with huge numbers. Okay, so let's look at, instead of writing 2 times 2 times 2 times 2, they came up with a symbol. They came up with a symbol which is a number that sometimes is called a power. Sometimes I think they call the 2 the base, and this, in any case, the smaller number I call the exponent. And in this case, so it shows what we've done above. It shows 2 multiplied times itself 5 times. And so, and we speak of it as 2 to the 5th power. So if you see 2 with a small 5 on it, that's 2 to the 5th power, and what it means is it's 2 multiplied by itself 5 times. So we can say that 2 to the 5th is equal to 32. And we've created a shorthand, and you might find that these can be difficult, but one of the things you can do, they're not really, but just remember that when you see 2 to the 5th power or any kind of exponential writing, don't multiply the 5 times the 2. That doesn't work. Just recognize that it's 2 taken by its 2 multiplied by itself 5 times. So 2 to the 5th we call it. So most of the time, very often, we'll use just 2 to the 2nd power, some number to the 2nd power. Also, when you see that, it's called squared, and later on in geometry you'll see that it's because when you multiply with a square, the sides, one side multiplied by itself will give you the area, I believe, of the square. But in any case, for the time being, 2 taken by itself twice, 2 times 2, would be called 2 squared, and is equal to 4. 2 times 2 is equal to 4. So you can see how that works. Now, there's an opposite of taking something and multiplying it by itself, and that's called the square root. So we can do the opposite. 2 squared, we will call 2 squared equals 4. We use this thing, I think it's called a radicand. It's nice that your teacher is sure of everything. This is the radicand. When you put it over a number, it means we're going to look for a number when multiplied by itself equals this thing. So for instance, in the square root of 4 is equal to some number multiplied by itself that will equal 4. When in fact the square root of 4 takes us back to 2 again. So this is important. We'll use other numbers for the base and sometimes other exponents, but for the time being, notice that we're working with things that are squared. 2 squared equals 4. The square root of 4 equals 2, so they're opposites. Which brings me to your calculator. When you're calculating these kind of things, it's wonderful, you know, because you might be working with bigger numbers than 2 squared. You might be working with, well, you know, 2500 squared or something. So you've got a squared button, and above it you've got a square root button. Because they're opposites, the button can work both ways. In order to use the square root function, you have to push the second button first. So if I want to square something, I hit the square button. If I want to hit the square root button, I have to do second and square. This is something you practice. And notice that the cat, who goes by the... Now I think we can do it. So what we want to do, let's say the first thing we want to do is find what is 2 squared. So rather than, you know, we know that number, but it's a good example. So what I would do is I hit the number 2, which would be here, of course. I hit the number 2, then I hit the squared button, and it becomes 2 squared on the screen. It's 2 squared. You don't do anything for the arrow. So that's 2 squared. Then you can hit enter, hit the enter key at the bottom right, and you'll get 4. So 2 squared equals 4. So, you know, that could be any number. We can square any number. But in any case, well, let's go ahead and clear that. So then we hit the clear button. If we want to go back the other direction, if we want to find the square root of a number, in this case 4, you'll start by hitting the second button, which is at the top. Then you will hit the square symbol. It exists not as a button, but above the squared button. So what we do is we hit the second, then we hit the square button. By hitting the second, that means we're using the top function instead of this. So we would start to get the square root of 4, hit the second button, then the x squared button, which functions as the square root, and we get second squared. Then it'll be empty here, and we hit the 4, the number 4, and 4 appears in there. And then you can hit the enter button, and that will give you 2. So that's how we find the square root of 2 using the calculator. So don't be too worried about exponents. Try to understand the concept of them and recognize, of course, that most often you will have a calculator available to do square roots of things, to square numbers and square root them. Okay, so that's the beginning of exponents. Now let's look at, before we do some examples of some sample problems of exponents, here's a few more rules regarding exponents, examples and rules. So again, exponents are very useful. Consider 5 times 5 times 5 times 5, or 5 times 5 times 5. 5 taken 3 times one way we can write it is we can say it's equal to 5 to the third power. 5 to the third power. They also call that cubed, but don't worry for now. 5 to the third power happens to be 125. So it's 5 times 5 is 25, times 5 is 125. So part of exponents is just that it allows us a shorthand, what they used to call shorthand, an easy way to write things. It's also an easy way to work with big numbers and avoid using your calculator if you don't want to use your calculator. Exponents are wonderful. Exponents are some of the most useful math. Now, any number taken by itself, or give to the first power, is equal to the number. So for example, 5 taken to the first power is 5. Hi, Marble. He's so sweet. Marble says, meow. Okay. It's good. 5 to the 1 is equal to 5. 5 to the 2 is 5 times 5, which we know as 25. This will blow your mind and blows my mind, but it apparently works in all the situations it needs to. If you run across a number to the 0 power, the answer is 1. That can be translated to 1. It makes no sense to me. I don't expect it to make sense to you, but somehow it works in things like algebra when we need it to. Now, if you see negative numbers, like this one where we have 5 to the negative exponent, to the negative 1, well, if it was a positive 1, it would be 5, but when it's a negative exponent, it becomes a fraction. 5 to the negative 1 is actually 1 over 5 to the 1, which is just 1 over 5. So 5 to the negative 1 is 1/5. And it's important for you to find some of these exponent problems and do them in whatever book you have or source you have, to do some exponent problems, because they can be multiplied and all kinds of things. But I'm beginning simply with these examples. 5 to the negative 2 equals 1 over 5 to the 2. So this is a fraction, 1/5, and that could be 5 over 5 to the 5 squared, of course, would go on to be 1 over 25. So this is a fraction 1/25. 5 to the negative 2 is 1/25 expressed as an exponent. So don't get worried about this stuff. Just realize that when you see a negative exponent, the easiest way to deal with it is just to change it to a fraction, and then you can continue with it. So with this one, we would change 5 to the negative 2 to 1 over 5 to the second power. And then if we want to, we can go ahead and make it 1 over 25. So that's an introduction to exponents, and you were also introduced to a most excellent cat by the name of Marble, Miss Marble. Okay, good luck to you all.